Good morning all and welcome to the webinar. The webinar is SOLIDWORKS Xpress Products. I am Rishi. I am Senior Application Engineer at Addonix Technologies Private Limited, and today I'll be walking through with all the features of Xpress products which are available in SOLIDWORKS each and every package. So what are Xpress products? So Express products, you can see SOLIDWORKS Express products are few analysis tools that comes with every SOLIDWORKS standard and professional software packages. Okay, so even if you don't have a premium license, you can take help of this to do some basic first pass analysis. Okay, so we have few of the products such as Simulation Xpress, Flo Xpress, DriveWorks Xpress, DFM Xpress and Sustainability Express. Okay, so I will quickly take you through each one by one. Okay, so in Simulation Express we can do basic static simulation analysis. Okay, and we can apply some force or pressure on the part and generate reports. So here we have SolidWorks part which is created in SolidWorks. Okay, then what if I want to test whether it is failing at certain load or not? So for that I will apply some boundary conditions, and you can see I have applied a force and I have restrained here so that I assume that there are some bolts going inside. Then I analyze and I create this result. So here you can see the red color, that means there is some problem area. So I must have to concentrate on that area. Either I have to reduce the load or else I can increase the material thickness so that the part is safe. Okay, so I'll quickly jump to SolidWorks. In SolidWorks I'll open the part, go to Express product, Simulation Express. I will open this part which I want to simulate in Simulation Express. Okay, so this is the part. Now I will go to evaluate and there is a Simulation Express wizard. Else I can go to tools, Express products and Simulation Express. Okay, so both ways we can do the Simulation Express. So I am opening this. First time I load Express product, it will ask me to insert a code. So right now I am clicking on this and it will jump into the browser wherein it will open like you want to log into your customer portal or maybe my.solidworks portal. So I am going to log in. If you don't have, you can create an account, that is not an issue. So I already have an account, so I will log in. So after logging in, what I can see is that there is a code. So here I will copy this code and I will go to SolidWorks and I will paste the code. So make sure that you are not adding any spaces before or after, and I'll click OK. So now in this way you have loaded a Simulation Express. The same goes for all the other Express products which I will be demonstrating. So here you have a basic detailed information about what is Simulation Express. Then in options, whether you want in SI or IPS, I am going for SI. The result location to be any if you want, but I am keeping it at a temporary location so that when my Windows will restart, the result local result will disappear. Okay, so that I can remove that. If I want to show annotation where is the minimum and maximum condition in the result, I can click here, click OK, I click next. So now here we want to have some criteria like how we go with the Simulation Express. So here we have an assistant, like first we will add a fixture, that is some bolts or something like that condition. Then we can add a load, then material, then we run the analysis, then we get result and we optimize something. Okay, so here we have some fixture criteria, that is the first one is selected fixture. I can go to fixture holes. You can see that the fixture is fixed holes. Then we have fixed versus supported, and you can see it is fixed and there it is supported. Then we have fixed and attached. Okay, so I am going to add a fixture. Either I can add a fixture from here or I can right click here and I can add a fixed geometry. So both ways you can do, but this assistance is very helpful if you are doing the first time analysis. Okay, add a fixture. I'll click these 4 holes so that these are fixed. I'll click OK. So here we have three options now. We can add an additional fixtures, or maybe I can edit an existing fixture, so that if I click here, you can edit this, or maybe I can right click and edit the definition, so that I can edit this fixture as well. I'll go to next. Now I want to add loads. Okay, I will add force over this portion of the rod, so that you can simulate them. Okay, so force I am applying on this bar, but you can see that the force is not in proper direction. So for that I will select a direction and I will select a plane. Okay, so I am selecting a plane. Okay, again the force is in wrong direction, so I will reverse the direction and I will apply some force in say 1000 newtons. I will click OK and I will click next. Even I can add a pressure or additional forces wherever you want, or maybe you can edit an extra existing force and pressure. Click next. You have the Young's modulus and yield strength, that is depending on the material which is applied. So when you apply a material, you can see that there is some yield strength available already. Okay, so the material strength is already defined, but if you want to change it, what you can do is you can copy the material and you can make a custom property wherein, so I am pasting it here. Okay, so I can paste here, or say I click copy this and I will paste here. Okay, so in this way I have pasted, and now these fields are editable, wherein you can change the material strength according to your vendor provided. So this database can be available from your material supplier, so they give a data sheet wherein you can enter the details. Okay, so okay, for the time being I am not changing anything. Then I will go to, if I want I can change the material. Now I think it is okay, that is cast alloy steel. I'll click next. So we have a change setting option, that is I can change the mesh density. So the mesh is like we are dividing the part into numerous small equal parts, so that and you can mesh it properly. So I am meshing it as per my requirements. So this is an arbitrary meshing. If I want I can show the mesh. So this is the mesh and I am going to run the simulation. Okay, so according to your geometry and the mesh criteria, it will take some time to simulate the result. And now we can see a nice animation of how the displacement will take place. If the loads and fixture are incorrect, the result of analysis will not be accurate. So that is the one. I stop the animation and I think it is okay. So I'll click yes. Okay, then we can see the wall masses stress, that is the yield strength of the material is this, and wall masses is the maximum is 1.27 into 10 raised to 3. Okay, so you have to see for yourself whether the value of wall masses is surpassing yield strength or not. If it is surpassing, then you have to make sure that the factor of safety must be more than 1, so that it is not failing. So I'm adding 3. I will check whether factor of safety is 3 or not. No, so here the factor of safety is not 3, that is the material wall mass stress is greater than the yield strength. So you will have to add a material, add thickness over here, so that you can increase the diameter and you can make it safe. Okay, then I can generate a report. So when I click here, you can see a pop-up appears wherein you can add description of this model, then who is the designer. Okay, so the designer, then the company, then the URL. Okay, so these kind of things you can add, and where you want to save this, and you can click on generate. So when you click on generate, you can easily see that SolidWorks automatically takes snapshots and all the boundary condition details which you have applied, and it will add up to the library. Later it will compose a word and then you will get a nice report. So let it create the report. So again, if you ask your designer to compile this type of report, it will be a hectic day for him. So instead of that, Simulation Xpress does a nice job of creating a report. So whatever I have entered, you can see the details, the snapshot and a description. So whatever force I have applied the mass volumetric properties, then the mesh fixture, then the load, each and everything is available. Then we have a mesh, then the results here, and you can see nicely, and then now you can share this data with the person who is asking for the report, or maybe with this you can conclude that your part is safe or not. Okay, so this was Simulation Express. So I'll close this. Okay, so that was Simulation Express, which gives you basic static simulation analysis on individual parts. Next I'll move to Flo Express. So what is Flo Express? Flo Express is basic fluid flow analysis tool. So what if I have a strainer wall or some pipe or something bent, and I want to show as a presentation to someone in SolidWorks that I want to see how the flow is going, or what is the parameter of the velocity if it is going through a small path or something. So here in this you can see an assembly which is having a strainer. This is a wall and a strainer, and you can see I have applied some boundary condition here, and you can see then the analysis result that an animation will show how the flow will go of water or air. Okay, so I'll go to SolidWorks. I will open this Flo Xpress option and the assembly. Okay, so let that assembly open up, and I will show you what can be done. So depending on your assembly, the type of features used, the time of loading will vary, and it is also up to your workstation, like which workstation and which graphics card you use. Okay, fine. So your assembly is open. I am making a section view of this. So now you can see a nice strainer in this wall. Okay, I'm clicking OK. So let SolidWorks rebuild the section view of this complicated wall. Then we can go to evaluate, and again there is Flo Express. So in Flo Express, what it will do is it will load the window for Flo Express. Okay, so actually I have already created the flow simulation, and it might load the result. Okay, so it is directly taking you to the flow outlet thing. Yes, so it is now loading the result because I had already created result for this, but quickly I'll show you how to add boundary conditions to this strainer wall. And depending on the assembly, again your flow result may vary. For in my case, result of this took I think almost 1.5 GB. So you make sure that your disk drive, wherever you are saving the result, is having ample amount of space. So I can, yeah, so just a minute, it will load. Okay, so you get a welcome screen like this, like you can see you can do flow in an assembly or part, whatever. Then when you click on next, this window will appear, but for this window to appear, you need the assembly to be in a closed condition, that is watertight. So here there are some openings in wall, but I have created two parts, so this part and this part, wherein I am pretty sure that it is watertight. Okay, so then I can show that where is the fluid volume. So for this internal analysis, SolidWorks will determine which is the enclosed area where the fluid probably can move, like from where to where it will move. So now it is calculating where my volume will be there. Okay, so now you can see that from here there is a enclosed space where my fluid volume will be there. So now I'll click on next, and I will say either it is water or air. Next, then I will add a mass flow rate, volume flow rate, or pressure as an initial step, flow inlet. So from here my fluid will enter, so I am clicking here, then I'll click next. Then I will apply a pressure, because in the first step, if I am applying pressure, then it will ask for volume, and if I am applying mass or volume or at the initial level, it will ask for a pressure. So I have applied a pressure, so this is normal environmental pressure. Then I will click on solve, but I have already solved. So, and you might have seen that it has loaded the result as well. So I'll click next, and you can see that I have some spheres and lines. So when I click play, you can see that the fluid is going over here and it is coming up till here. So and also you can see with the color coding that how much velocity is the maximum, that 5.193 meter per second velocity at the red areas. So that you can conclude with this that my thickness of the sections of my strainer must require some modifications or not, depending on this. Okay, so while you are creating this animation, okay, I can click photos of this. So I have captured a photo likely, then I will stop this, I will make it as a pipe. So you can see, and I will again play. So you can see a pipe flow of fluid. So it is going either way. I will capture these images. So I have two images. I will stop this animation, and again I can display the annotation like what is the inlet flow and what is the environmental pressure, and I will generate the report. That was regarding Flo Xpress. Now I will move to DriveWorks Xpress. So what is DriveWorks Xpress? With DriveWorks Xpress, I can create automated designs. So that is, if I have created an assembly, I can automate it with a form, input form, so that I can create a large assembly or a small assembly depending on my needs. Okay, so I will quickly open solid. Okay, so you can see that I have created an assembly, and this assembly I want to make the design automation. For that I will go to evaluate and DriveWorks Express. So again it is asking for a code. So again I will click on that link. I will copy the code which is available for me. I'll copy this. I will go to Simulation DriveWorks Express. I'll click OK. Okay, so now you can see that my assembly is open and I have opened this DriveWorks Express. So here I can create or change the database whatever I require. So here there is a database already created by me. So I'll go to DriveWorks Express and select the database. So either I can directly run this, but I will show you the steps like how we created this. So for that I will double click on this, and you can see that I have captured this base top base part and top part, which are the parts of this assembly. Then I have captured the model from this assembly tree. So while we load the assembly, all the parts are available, but I have selected only these two things which are going to change overall. Okay, then I have added a drawing which will be updating whenever I change this assembly. The next thing is form, wherein I will be inputting this height, width and length of this assembly. Okay, and it will be according to my needs, whether it is numeric text box or maybe a drop down list. Okay, then we have a rules page wherein I am going to add the rules, that is the dimension which I have captured must be linked with the form which I have selected. So whenever I edit some values in the form, it will automatically change the values of these dimensions. Then after I have done all the things, what I can do is, whenever all the rules are created, you can see there is no missing thing. So all the 9 entities here are done. I'll go and click on run. So now it is asking me for a height. So approximately, let's say 150 mm is the height. The width maybe 300, and the length I am taking it as 1000. Okay. Then I will click on create. So whenever I do this, SolidWorks will automatically resize your assemblies, parts, and it will automatically create the manufacturing drawings ready for you. So creating this like creating the database is somewhat difficult and time consuming, but after creating this database your life will be very easy, so that you can see that each and everything is created, and again your assembly is renamed according to your dimensions. So in this way, like in a single click, you can take help of DriveWorks and do automation on your products. So that is DriveWorks Express. I'm not saying this. Yeah, I'm closing this. So that was DriveWorks Express. Then we have DFM Express. So what is DFM Express? DFM Express validates the manufacturability of part designed with SolidWorks. So what if I have some tools available at my workshop, but it is not known by the designer, and designer creates fantastic designs. So suppose in this model, what I can see is that there are some holes created, but at my workshop I have limited tools which are larger in size. So with that, this DFM Express, it will show that these holes cannot be created. So I can set some rules for this DFM, like for milling or maybe grinding, that my certain things are available, and DFM will make sure that you recognize the things that you have done some mistake, and you can change it, and you can see the rules are available then. Yeah, so I'll close DriveWorks, it is not required as of now. I'll go to DFM Express. I will open this block. Okay, so in this block you can see that there is a sketch. The holes are 50 mm, 20 mm, 30 mm, and that is 75 mm. Okay, so the dimensions are pretty sure that these are the diameters of holes. I'll go to evaluate DFM Express. So again it is asking me for a code, so I click that. I will activate the code. So generation of this code is a one-time process. So when I generate this, I don't have to generate it ever again, it will automatically appear. Then I can go to setting. Here we have a lot of options like milling, drilling, turning on with milling, drilling, then sheet metal, injection molding. So I'll click on mill drilling. So because I want to, so here in hole depth to diameter ratio, it is less than or equal to 2.75, and minimum hole inside. So these are the basic things, or maybe I can standardize it according to my requirements. Okay, so I will directly click on run, and you can see that DFM Express will show me some errors, that this highlighted hole depth to diameter ratio is 6.67 in actual, but the maximum recommended is 2.75. so I need to either change the depth of this or maybe increase the height of this diameter of this. The same thing here. So what I will do is I will simply edit the sketch and I will change the diameter. So this may be 50, this is 55. I have done this. So now I will again run this, and now you can see that there are no rules failing, so that each and everything is in proper order, so that you can say that my tools or maybe whatever rules I have selected are in proper way. Again I will show you another example of DFM Express. This is the sheet metal part. I will open that. Again I will go to DFM Express wizard, I will go to settings, then again we have sheet metal, wherein I can show what is what ratio. Okay, so recommended bend radius is 5.00 mm in this case. Like I can say that at my workshop I can do bend of 5 mm or more. Okay, so I'll go to run. Again DFM Express will do the basic analysis of this product, whatever you have created in sheet metal. Then it will say some failure things. So okay, so first of all it is highlighting something. So here the bend radius is 0.74 mm. The designer has created a wrong bend, but the recommended bend is this. So in this way the designer can check for himself like what thing he has available, or maybe what thing he must do in designing so that it can be easily manufactured at his place. Okay, so this is DFM Express. Now we have Sustainability Express. So you might be knowing that there is a flow of product creation. So from starting from the production state to the end of life, this is a chart. Like raw material is extracted, then the material is processed, then it is created for a part, it is gone for a part creation, then assembly is done, then the product is sold to the customer, and after some few years the product is of no use, so end of life is there. So Simulation Express is a tool wherein you can perform screening life cycle analysis on individual part to help you understand the environmental impacts of your design decisions. So this analysis can be done with TRACI or CML methodology. So we have a lot of methodologies in the market, but TRACI and CML are used by Simulation Express, and with this methodology you can indicate the impacts on the environment. So these are some of few of the environmental impacts available. So I'll quickly jump to SolidWorks. I will open, so for the time being I don't require DFM Express. I will open Sustainability Express. So I have a plastic spoon and I want to see what is the impact of this on the environment. So I'll go to Sustainability, let it load. So when you load Sustainability, you get a nice dialog box wherein you can see the process flow of your product or maybe any product. So the raw material, then the material processing, part manufacturing, assembly, product use and end of life. Okay, so I'll click on continue. I can change the material from here also, but for the time being I am wishing to do analysis with the PC high viscosity. Then I can change the region. So I am in India, I want to change it to India, or else I can directly select from here that my manufacturing region is India. Build to last, like how much years I am thinking to make it last. So let's say 2 years maximum. What is the process used? So injection molding. How much is the electricity consumed? How much is the natural gas consumed? These things you can enter here. If it is a paint or maybe powder coated paint, so it will create the calculate the surface area and automatically create the required result. Then where you are going to ship. So if you are going to ship in India only, you can click India. So I am thinking to ship my product to South America, so I am clicking here. Accordingly it will do the shipment distance. I can even add additional transportation example. So like 300 miles my product will transported by train, and the truck will be by 30 miles. Then okay, I'm not doing shipment with flight, so I'm not adding this. Then the end of life is the percentage of how much it will be recycled, how much it will be incinerated, and how much it will be landfill, that is a dump. So duration of life 2 years, and you can see the carbon emissions and all the relevant data. Okay, so I have these two options. So what is TRACI? So tool for reduction and assessment of carbon and industrial effluents in environmental aspects. And CML is a methodology created by the Institute of Environmental Studies. So we have two methods available. I can click on any of this and I can generate a report. So in this way you can take help of all this Simulation Express, Flo Xpress, DFM Express, DriveWorks Xpress, sustainability to improve your daily designing process. So about me, I am Rishi More. I am Senior Application Engineer at Addonix Technologies. I look after some of the products in being at Addonix, and this is my email address. So if you have any queries, please feel free to call me. Yeah, thanks. Bye.